Hi team, today we're going to discuss about material that's used for turbines to be made and how these turbines survive in extreme conditions. So our turbine blades are used in jet engines and power plants that can endure until temperature reach 1500 degrees Celsius. Also, it also spinning at the same time in thousands of RPMs. To withstand these extreme conditions, material science help these blades to withstand such conditions. So this is picture of turbine blade used in power plant and then our jet engines. First, there are enemy for our turbine blades, which are oxidation and hot corrosions. High temperature can cause oxidation, where it can forming a brittle oxide layer on the surface of turbine blades. The hot corrosion also has some contaminants like sulfur, salt, which accelerate the material degradation. Without protection on the turbine blades, it can fail within hours, so it cannot withstand such extreme conditions. So we can see how the oxide layer affected our turbine surface. Initially, there are gaps between atoms where the oxide layer will be filled, and later on the water makes whenever contact, it will start to react with the water and it will be start ferrite oxide, where it will start the rusting will be occur. So whenever times take, the whole surface will be start to rust. To avoid this, we need to carefully to select what type of material we going to use. First, we can use nickel based superalloys like Inconel 738 CMX4. So it help to provide oxidation resistance like chromium oxide protective layer. Also, it like creep strength like nickel aluminum layer. This layer also help thermal factory resistance towards by using single crystal structures. This also offer to resist corrosion and handle extreme heat, but also brittle. But we are using material science to overcome these issues. So we can see how the superalloys are withstand in such pressure, high pressure and high heat. As long the pressure increase, the stress also increase. But compared to nickel alloy, the superalloys when treated, it can withstand high heat and also high stress. So we also can coating the force field, so it helps increase the lifespan of the blades. So we can use TBC as known as thermal barrier coating, which reduce temperature of the blade, surface temperature of the blade by 150 degrees Celsius. Also we can use a coating which is known MAC hair oil, which is made up of copper, nickel, where it coating itself healing the aluminum oxide protective layer, which is used previously for the surface of turbine blades. This coating also significantly improves turbine efficiency by reducing cooling the air needs. So there is no need for extra air to supply to the turbines to cool the blades. We can see the cross section of the turbine blades with thermal coating. So how the coating helps the turbine surface not affected by the oxidation. We can see the insulate thermal barrier coating provide from the thermal, and also the aluminum oxide also protecting from the oxidation. So these two coatings help prevent the corrosion or oxidation on the blades. So as we see that our blade's surface, whenever got heats up, the outer layer aluminum top coat is protecting from the high heat, and the second layer also helps from the corrosion and oxidation. There is a process we can help for the increase our lifespan by alloying and processing. We can use chromium for oxygen resistance. We can also use aluminum for ultra stable aluminum oxide protection, and then we can use rhenium enhance our creep resistance. It helps eliminate our weakness of pure surface of metal turbine by adding these alloys, so it increase its resistance against oxidation and corrosion. So lastly, we have to know what type of material we need to select for material to be used for the turbines and its coating to ensure its turbine longevity. Also, we need, although we achieve some coatings and alloys right now, but we still need to invent new type of alloys and coatings so we can increase the lifespan of turbines. Recently, we know the turbines used in rocket engines can be reusable, as the Elon Musk has created his own reusable rocket packs. So to achieve this kind of technology, we need to invent more innovation that our turbine blades in those jet engines and the power plant should be withstand more stress and heat. So as our students, we should focus on how this material science helps us to increase the strength of the materials to withstand high heat and corrosions. Thank you.